So if you haven't watched the previous question, I would suggest watching that first. It says a mixture of nitrogen and hydrogen has a total pressure of 1.31 atmospheres. If the nitrogen in the mixture exerts 0.181 atmospheres of pressure, what is the mole fraction of each gas? Well, there's a couple of things that we need to know here. One equation we need to know is that the pressure of nitrogen is equal to the total pressure times the mole fraction of nitrogen. And as discussed before, the mole fraction of nitrogen is the same as the percentage of nitrogen in the mixture, the percentage of moles. You just don't multiply by 100. So basically, fractions out of 1, percentages out of 100. But the other thing we need to know is that how are we going to rearrange this, basically, in order to find the mole fraction of nitrogen? Well, what we're going to want to do is divide by the total pressure. So we're going to find the mole fraction of nitrogen is equal to the pressure of nitrogen divided by the total pressure. And when we do that, we're going to take the total pressure, which is 1.31, and use the pressure of nitrogen, which is 0.81. So we have 0.81 atmospheres on the top, and we have the 1.31 atmospheres on the bottom. And when we do that, we're going to find that the mole fraction of nitrogen is 0.62. Now, there are several ways you could find the mole fraction of the hydrogen, all right? But the easiest way is to realize that this mixture only has nitrogen and hydrogen. So if its mole fraction is 0.62, or said another way, it's 62% nitrogen, the rest of it has to be hydrogen. So to find the mole fraction of hydrogen, we want to take 1 instead of 100 minus 0.62, which is 0.38. So by moles, it's 62% nitrogen, so its mole fraction is 0.62, and by moles, it's 38% hydrogen, so its mole fraction is 0.38.